In this thesis, we explore theoretic aspects of mathematical models that are used in analysis and design of hardware and software. And more concretely, we focus on finite and weighted automata, push-down automata, and context-free grammars. These models are mathematical objects that accept or generate languages, which are a set of words. And in this way, they are widely used in applications such as the design of compilers, in text and speech recognition tasks, or program verification. These applications strongly rely on language theoretic notions around which still today many questions are open. So the goal of this thesis is to give new theoretic perspective on a collection of open questions that are at the core of classical automata constructions and well-established algorithms. The underlying mathematical tool that we use to approach these problems are equivalence relation on words. So in this thesis, we mainly address three questions. First, we focus on automata minimization algorithms. These are methods that essentially minimize the number of states in a finite state automaton. And concretely in our work, we aim to give a common language theoretic basis to a collection of apparently independent automata minimization methods. To do that, we propose a framework of automata constructions that are based on equivalence relation on words, which are finite. Second, we address the question of whether push-down automata are more concise than context-free grammars for the representation of context-free languages. Now, instead of comparing these two models when they both represent the same languages, we compare them when they represent almost equivalent languages. This notion of almost equivalence is what we more concretely call paric equivalence. So paric equivalence is a weaker version of the usual equivalence on words, in which we essentially ignore the ordering in which symbols appear in the words. As a result of this work, we prove, generally speaking, that push-down automata are more concise than context-free grammars, even if we are just interested in paric equivalence. And finally, we address the question of extending Parik's theorem to weighted automata. So one of the reasons why paric equivalence is an interesting notion of equivalence is in good part due to Parik's theorem. Parik's theorem is a celebrated result in formal theory that has been proved useful for the analysis of asynchronous programs. However, Parik's theorem is not true for the more general class of weighted automata. So these are automata that do not only accept or reject words, but they also augment words with some weight, and therefore they are useful for quantitative analysis of programs. So in our work, we study under which conditions the paric property holds for weighted automata. So to sum up, in this dissertation, we leverage equivalence relation of words to give new and general perspective on a collection of open questions on classical automata constructions.